This is a pretty short summary or an overview of the experiment I've been working on, which is a rotor centering plates that, once fully assembled, make a usable electric three-phase motor out of the Honda IMA motor parts that you can get for fairly cheap. And as you can see, it does work. This is I believe, a Generation 3 Civic motor, a motor with heavier windings. This experiment took me, well, I basically started this experiment because I didn't see anyone putting out the CAD models of this motor, at least the proper dimensions for where all the holes are and everything. So that's why I decided to do it, because I saw nobody else did. So it took me on and off for almost a year. I'm going to show you some pieces from the assembly process that I took the shots earlier. But overall, this is how it looks once it's fully assembled. And as a note, this is not a version that you could put straight to the vehicle because of the 3D printed parts. This is more like a lab environment motor. And together with this spinning rotor, I consider this experiment done. If you think you could use the drawings or the sketches for the plate, the CAD models, let me know in the comments. I'm going to put down. I'm going to share the files for sure. Okay, so let's dive deep into the assembly process and learn from the mistakes I made. Cheers. I'm going to go all over the parts and explain a little bit before continuing the assembly. So to start with, we have this offset, right? We have the frame and we have the stator here, and it has this offset. So to compensate that, I 3D printed a spacer. I think it's 25 mil spacer that goes here, and its sole purpose is just to offset the sidewall. If you would be converting this motor for something useful, like I don't know, converting a classic car or whatever, that could use 15 kilowatts of power. I would suggest using not 3D plastic for sure, but like rather aluminum. Cut 5 pieces of aluminum and just make a sandwich. And the second issue we had was these holes. These holes are like 13-14 mil. So to work on that, I actually bought off a fitting aluminum tube that has 8 mil inside, and I'm gonna basically glue this in right here, like so. And it will basically make usable hole here. And that's what I'm gonna do right now, I think. Yeah, and then we'll proceed on the shaft and other stuff. Okay, so while the glue is hardening, I'm gonna briefly explain the matter with the axis. So I had a couple of attempts on how to make this properly, and the thing that worked for me was I basically 3D printed this kind of mount. I put it on to position the plate, and I added two welds to hold it, just for now. Right now I'm gonna add more welds to it. But what it did, basically, it positioned the plate vertically at a perfect 90-degree angle, and well, it minimized the warping. I can say that because it worked, apparently. So I hope that's what happened, because previously what happened was basically the whole plate lost its shape, like it warped in all different directions. So yeah, that's what happened, and this seemed to work. And the whole idea of the shaft is that I insert the shaft from one side and I bolt it from both of the sides so that I can always disassemble it. Well, at least that's the idea. And this is the plate. So the shaft goes in from the other side. We have another plate that bolts up from this side, and then we have this bigger plate that's also going to be welded on the shaft, but I'm going to show you a bit on that later. Here, as you can see, we also have certain spacers, but these are actually 3D printed, just because we just need them to be in the middle. Like it doesn't do any much of the work. The same goes here. These are not, like, it's not mandatory to glue them in, but that's what I did. It will make things easier at the end of the day. Yeah, I guess I'm gonna proceed with welding this on. So I added a bunch of welds. Let's hope it didn't warp it. And yes, I am missing one rivet, but for this sake, I don't think it really impacts, because at the end of the day, this is not holding all the force. Like, this plate is also going to be helping out. So I'm pretty convinced this is enough. And right now I'm going to be trying to slowly assemble it without moving these while the glue is still hardening. And also, one more step we're going to be doing is, that are really important, is making positioning spacers. These positioning pins that are exactly 14 mil, and I have this 14 mil thing. I'm gonna cut a bunch of pieces because 2 are from this side and 2 are from other side, and these are gonna be majorly helping us to position the main plates. So that's what I'm gonna be doing. Well, if you had any question why the shape of this plate was like this, it's because it has to fit. The fact that all of these holes align perfectly means only that the shaft is really in a 90-degree angle from here. So this is beautiful. These bolts are actually the stock ones. I didn't change them, but I did have to cut the heads of it, grind the heads of it just a little bit, because you're gonna see when I add the main plate on this side, a little bit of the bearing holder is actually touching it. So I just had to grind it away. And the reason I'm bolting it up is because I'm gonna add some welds here as well, just to make sure it helps the little star-shaped plate as well. So with the shaft welded on, with the plates welded on the shaft, I'm gonna let it cool down. I don't want to apply any more heat. I might even loosen those bolts a bit, just not to transfer all the heat to the magnets, but it's not a big heat, I can keep my hand on. So what I'm gonna do now is, as I said, I'm gonna cut a bunch of positioning things here. We have 2 different main plates. One is with this little piece, another one has a little bit different curve here. But in essence, the purpose of them is to center the rotor axis, and for that I did a lot of work, but eventually it came down to 3 pieces. One is the main plate, another one is a 5mm to make it thicker at the middle so I could insert a proper bearing, and one is the end cap, which I just taped and bolted with the M6 bolts. Well, the taper will remain there forever. Maybe one lesson I learned from this was that I believe when the laser was cutting this piece, since it's pretty small and pretty thick, it got really hot, and maybe he cooled off. Yeah, it was probably dipped in water because it was so hardened. I had to use a lot of energy to make the taps work, but eventually I made it work. So yeah, these are done. The 14mm inserts are also done. So I think I'm gonna start with the assembling it. Oh, also I added all the bolts here. I'm gonna start assembling it from this side because yes, it requires more to push in here, but there are no aluminum things to go through, so it's gonna be easier. Well, and I don't think these are fully hardened yet, but I mean they're pretty decent, but yeah, just to be safe. Not sure if you could see that, but like having the inserts made the work so much easier. You have no idea, because what I used to do is I used to use these bolts to navigate it and position it, and right now I'm pretty sure these things came with the stock unit when I received it, but I think I lost them somewhere in the middle of processing, because keep in mind this was the process of like whole 1 year more or less. So okay, one side is done. I'm gonna add the insert now, the spacer. And for you, a note for the future, don't make it 25mm, make it 30mm, because what it gives you, it will give you a little more space here, so you can play around with different bearings, with different things. Actually, I need to measure this if it's not going to be touching the bolts, because I see these ones are a little bit above the surface. Yeah, let's do that. Here's what it looks like with the offset on. I'm gonna add some grease here and add the final plate, and then bolt everything up. Oh, almost forgot the inserts as well. Yeah. Just a quick note, the bolts I'm using are the M8 ones. They basically go all the way through with their thicker part, and then the thread begins. I guess this is just pure luck that I managed to find. I mean, ideally it should be a little bit longer, like 1 mil longer, but essentially what I found, the ones that had I believe it's 95 mil between this and this point, so that would have enough, and then I'm just gonna cut off the thread. Yeah, but that makes that helps with the position. Okay, Mr. Genius here. Turns out this hole was 13 mils, while all the other holes were correct at 14 mils, and I was basically trying to force that in. That is until I realized I can just measure stuff. So yeah, long story short, as soon as this got clipped in, the motor is now spinning without any sound, which means my whole sweat and tears were not for nothing. I'm just gonna finish adding up these bolts. I used to add them in, I would add one on one side, another one on the other direction, so that eventually they would even out and basically I was doing that because of these, because I was not using these inserts. Yeah, so I'm gonna bolt everything up. There's a way to see. Okay, I cannot turn it on, but perfect. Spinning perfectly. I'm gonna cut off the remains of these bolts, and I don't think today I'm gonna hook it up to the controller. I do have a controller though. Here's a 50-volt battery we made. And this is gonna be the controller I'm gonna be running. I'm not sure the power of it though. Okay, it's 44 volts to 72, so like 50 volts at 340 amps, so that's like, should be enough, like peak should go up to 15 kilowatts, so I'm not expecting any more from this, otherwise it will heat it up and it will probably wrap this plastic, but since we have the aluminum inserts, this should be no issue whatsoever. The sandwich is being held up pretty nicely. Long story short, I did manage to miss one important detail in the previous day assembly, and that is the Hall sensors. So the controller always knows the position of the motor. I was actually used to encoders. That's probably why I didn't even think about the Hall effect sensors. But then I read the manual of this Kelly controller, and it says it doesn't work without position sensors. So I purchased a few Hall effect sensors. For the sake of this experiment, I actually tried a few different angles for the Hall sensors. And again, this is because this is for just a lab environment and not actual like vehicle. I'm just super gluing those in and testing it out. So this is the configuration I'm going to be sticking with, and it seems to work. Again, for normal use, for normal operation in a vehicle or something, I would highly recommend not using Hall sensors, but rather just sticking with encoder and proper inverter. Since this is my lab and I'm using the Kelly control, I need to stick with Halls. So yeah. And as you can see, it works. I hooked it up with a random controller I had. I wasn't able to hook it up with the Kelly controller though. There was something with the Hall sensors, and this random controller made it work. Overall, I love the build, I love the motor, I love the dimensions of it. It really reminds me of the actual flux motors, except this is like 10 times less powerful in the same weight and size ratio. But I mean, it's beautiful. You can get it for like 150 euro or something out of used cars. So definitely worth a check-in. You can use it for small electric vehicle, motorcycle, I don't know, maybe a generator. But yeah, once it's assembled, it's a pretty beautiful looking motor.